Today let's see matrix in algebra, that is chapter 3. Have you come across this matrix? So far you haven't, isn't it? Here only you are going to learn it off, and in higher classes you will be learning. This is a basic one only. Matrix is just like a game only, it's just we can have fun. Okay, here matrix is a rectangular array of elements. What is matrix? Matrix is a rectangular array of elements. The horizontal arrangements are rows and the vertical arrangements are columns. In general, matrix will be arranged like this. After arranging the elements, we have to put a bracket like this. Clear, ma? First we'll see what is a row. Here in classroom, how will you be seated, ma? You'll be seated like this, isn't it? That is, you'll be seated. Am I right? Like this, you'll be seated. And the person sitting here are sitting in the first row. And here, the person seated here will be the second row. Am I right? This will be read as rows. That is first row, and this one will be considered as second row. So when you are arranged in your bench wise, then we say it is rows. And what about the columns? Imagine that you people are standing in the assembly. How do you stand? You'll be standing one behind the other, isn't it? Like this. Am I right? One behind the other. So here this type of arrangement is said as columns. So sitting in a bench, that is sitting in a bench is the arrangement of rows, and standing for an assembly for a PT period while going you will be standing, no? That you consider as columns. Okay. So here the arrangements of rows and columns in a rectangular array, that's only called as matrix. Okay. We'll see how to write the matrix. See here, this is how we'll be writing the matrix. We'll be arranging the elements in this way. And we'll be putting a bracket like this after arranging the elements. This is how we note the matrix. Okay. And now just we'll have an example. 4, 5, 3, minus 1, 0, 7. Here 4, 5, 3, minus 1, 0, 7 are the elements here. Okay. And now you see this one 4, 5 and 3. They are in the first row. And this one minus 1, 0 and 7 are in the second row. And now see here, this 4 minus 1. It is in the first column. And this one 5, 0. They are in the second column. And this one 3, 7. They are in the third column. And positioning of these elements, they are positioned in the matrix. See here, this 4 is positioned as A 1 1. That means it is in the place of first row and first column. What about this 5? This will be A first row second column. This position is 3 position is A first row third column. What is the position of minus 1? It is A second row first column. What is the position of 0? It is A row is second row second column. Position of 7, it is A second row third column. Are you clear, ma? How to find the position of the elements in the matrix. Order of matrix is nothing but M cross N, where N will be the number of rows in a matrix into number of columns in the matrix. So to find how many elements are there in the matrix, we have to multiply the number of rows and the number of columns. You will get the number of elements in the matrix. And the order of the matrix is M cross N, where M is the number of rows and N is the number of columns. See here, in our example, this matrix 4, 5, 3, minus 1, 0, 7. Here, how many rows are there? 2 rows, isn't it? And how many columns are there? 3 columns. So, the order of the matrix is 2 cross 3. And see how many elements are there? 1, 2, 3, 4, 5, 6. So, here how to calculate it? Number of rows into number of columns. 2 3s are 6. So 6 elements are there in this matrix and the order of this matrix is 2 cross 3. And tell me the order of this matrix. What's the order of the matrix? Order of the matrix is M cross N, isn't it? What is M? How many rows are there? This is first row. This one second. And this one third. And here first column, second column, third column and fourth column. So here what is your order of the matrix? Number of rows 3 into number of columns 4. So your order of the matrix is 3 cross 4. And now can you tell me what is the position of this 3? Where does this 3 stand? It is in the which row? It is A second row, isn't it? Second row, second column. Can you tell me the position of this one? Element 4. It is A, third row, first column. Clear, ma? Yes. We'll see the types of matrix. First one, row matrix. From the word itself, you can understand what it is. The elements will be arranged in a single row. Then it is said as row matrix. For example, 4, 7, 9, 3. It is a row matrix. Then next one is column matrix. Here, yes, the elements will be arranged in a column, in a single column. Okay, this is column matrix. And next, third one, we can say square matrix. Square matrix, square means all the four sides will be equal measurement, isn't it? Same wise, here it will be m and n will be of same number of. Square matrix means the number of rows and the number of columns will be same. 3, 2, 1, 4, 7, 9, 0, 3, 1. Here how many rows are there? 3 rows are there and 3 columns are here. We can give one more example. 2, 4, 6, 0. Here 2 rows and 2 columns. So this is a square matrix. Next one, diagonal matrix. Diagonal matrix. See here, diagonal matrix will be always a square matrix. In a square matrix which is diagonal, this is diagonal, isn't it? That's what. See here, in a diagonal matrix, 3, 4, sorry, other elements will be 0. In diagonal matrix, only the diagonal will have some value, other elements will be 0. Yeah, can you see, ma'am? Only in the diagonal you will be having the value. Okay, and now come to scalar matrix. Scalar matrix. In a scalar matrix, the same as diagonal matrix, there is a small difference. That is, only the diagonals will have some value. Meantime, the diagonal value will be same. See here in diagonal we are having k's, isn't it? K. So this we say a scalar matrix, and in diagonal matrix the diagonal will can have any values, and in scalar matrix we have the same value. Here we can write like this also, ma. 3 0 0 0 3 0 0 0 3, right? Next, identity matrix. Identity matrix is same as a square matrix. Here it's a square matrix. Meantime, it is a diagonal matrix with the diagonal having the value of 1. The diagonal will have the value of 1. Then we say it is a identity matrix. And now what is zero matrix? All the elements in a matrix will be 0. Then we say it is a zero matrix. Okay. And then transpose of a matrix. Listen carefully, ma. Here, if the elements are arranged like this, A, B, C, D, H, I, J, K, W, S, T, and U. If this is one matrix A, then what will be the transpose matrix of this A? It is the interchanging of elements. Transpose of the matrix is the interchanging of the rows and the columns of the element. It is the interchanging of elements of the rows to columns and column elements to the rows. See here, what is your first row element? It is A, B, C, D. So this row A, B, C, D will be written in the column A, B, C, and D. And what is your second row? H, I, J, K. This H, I, J, K will be your, what is the second row? H, I, J, K. This H, I, J, K will be your column now. That row will become a column. H, I, J, K. And your third row is W, S, T, U. That will be taken as the third column. W, S, T, U. The bracket, that is matrix. Clear, ma? And next, triangular matrix. Here, in a square matrix, we have two triangles. One is the upper triangle and the next one is lower triangle. So here we say if the matrix is an upper triangular matrix, then it will be like this. 1, 4, 5, 0, 3, 7, 0, 0, 6. If it is a lower triangular matrix, then it will be 1, 0, 0, 6, 4. Now you see, you can form a triangle. Yes or no? In the upper part, okay, the triangle is formed in the upper part. So we say this is a upper triangular matrix. A triangle is formed here. Okay. So this is a triangle is formed below. So it is lower triangular matrix. Next is equal matrix. Here in equal matrix we consider two matrices A and B. Here the two matrices A and B are equal. If they are equal, then the elements found in their position will also be equal. If this is 7, 3, 2, 1, then here also you have 7, 3, 2, 1. The position of this one is A 1, 1, isn't it? So these two are same. Here the position is same. Here same. They are equal and same. So we say it is a equal matrix. And now what about a negative of a matrix? Now you consider matrix A as 3, 7, 2, 5. This is a positive matrix. That is matrix A. A is equal to matrix 3, 7, 2, 5. Now we have to write a negative of this matrix. That is minus A, nothing. Okay. So minus A means here also you will be getting minus, that is 3, 7, 2, 5. This is only negative of matrix, or else you can take this minus inside. When you are taking it inside, you have to multiply with the elements here. So this becomes minus 3, minus 7, minus 2 and minus 5. That is minus into plus becomes minus, minus into minus plus becomes minus, minus into plus it is minus, minus into plus it is minus. That's why you are getting like this. Okay, ma? Yes, tomorrow we will do the problems under this, ma. Just the concept alone, just to go through it thoroughly. Then only it will be easy for you to work out the sums. Okay, see you back.